Today we're going to go through a program called Data Intensive Farm Management. It's a new program based out of Illinois. It's a national project working on farm research projects and kind of how to streamline them and how to set them up on your own farm. It's called DIFM, or Data Intensive Farm Management. We're going to go through kind of how to set up a trial today and what that looks like. So we're first of all going to navigate to the website. We go to DIFM.farm. And it will pull up here. The next thing we're going to do is we're going to go over here to, we're going to go in and sign in, and I'm already signed in. All you need to do is make an account and you can sign in anytime you want. After that, if we want to set up our first trial, we're going to go to Farmers and Advisors tab right here in the middle. We're going to click on Farms. And here I already have some demos that we've done, but I'm going to go ahead and do this from the beginning. So we're going to go to Add Farm. And here you can enter an address, you can enter the farm name, you can do latitude, longitude. This kind of sets you up to where you are next. But I'm just going to leave it where it's at for this example. And we're going to go ahead and add a farm. This is just going to be our corn N test. So I'm going to put 2 just so it doesn't confuse it with the other tests that I've done. We're going to click Save. So now it brings us back here, and this is the test down here, right here. We're going to go ahead and go to Fields next. And here, this is where it'll bring you kind of where we were on that last page. So if we want it close to our farm, we put an address. We can do a few things. We can draw the field, or we can upload the field. I'm going ahead and just upload the field to make this simpler. So we're going to name this trial corn N. And this is the name of the field. We're going to open up, we're going to drag and drop a file here. So I'm going to open up on my files that was given to me through DIFM. So we're going to go here. This is my DIFM folder on my computer, and click in here. And this one has them all zipped together. So I'm going to go ahead and unzip them. So I'm going to extract the files. I just want them where I'm at. So now we have our 2025. And we're there are several examples here for different trials. We're going to first work on our corn nitrogen trial. So I'm going to unzip this one. So once I have it unzipped, I can click in here, and then I can see my other files. These ones don't need to be unzipped right now. We're going to go to our boundary files. We're going to drag and drop it over to here. And then we're going to click Upload. Once we have uploaded that file, we can see it goes to the field in the area that we have it in. This is in the middle of the field. And then we're going to go to, next thing, this is our trial, our field. We've already uploaded the field, so now we're going to go to Trials. For this field, I'm going to add trial. The trial name can be anything you want it. For this one, we're just going to do corn N test. The year is 2025. The crop, we're going to do corn. This right here, we're going to mark it as a test trial. This is so it doesn't go into the DIFM database and tell the administration that it's there for other funding. If we do this officially, then we'll unclick that, but this is just an example. So we're going to set that up. So now it takes us back to the trials page. We can see we're incomplete. The next thing we need to do is go to the gears right here, this green icon. And this is where we're going to configure our trial. So here we can see the field, we can see the area we're going to work in. First thing we're going to do is add an AB line. And here you can do a couple things to add an AB line. You can use a latitude, longitude plus a heading. So you put your longitude, your latitude, and then put a heading in there and name it. You can do your start and end points. So you do latitude and longitude for your A and your B. Or you can do is upload a shapefile. And we have a shapefile from the farmer that we're going to use for this one. So again, we're going to go down to our zipped files. We're going to find AB line zip. And we are going to drag and drop it into here. And then we're going to to click save. Oh, so we need a name. We're just going to name this corn NAB. Okay, so we have our AB line. It doesn't matter that it's not in the filled area. This is just the straight AB line we're going to use to set up the direction of the trials. So now we're going to move down to our configure the trials. Now we move down to this trial configuration area, and we're going to click add edit. So this is where we need to do all our measurements. So we're going to use the measurements of feet. The harvester we're going to harvest this corn with is a 20-foot header, and the headland distance is going to be 150 feet. So this distance they just like to keep at least within the headlands, and then a little bit more for some extra distance so we get the treatments in and not the turning around areas. The sideland distance here we're going to use 20. Input plot minimum length, maximum length, you can change this around to see how big, how long each of those trials you want to be minimum as far as the input distance. Then we're going to click on done. It's going to take us back to the trials page where we put our AB line in. We've now configured our trial configuration with our harvester width, headland distance, sideland distance, minimum, maximum plot length. So now we're going to work on inputs. This is the specific part that we want to do. So now we're going to go to our inputs. So it has some details that are already brought in from other places. So 2025 corn. Category here we're going to do nitrogen. The input is UAN 28. The metric or the units for the input is going to be gallons, and then it's on per acre basis. So now that we need to know more about the machinery itself, so we already know the harvester width. We need to make a machine for the applicator to put down the nitrogen, and this is where we're going to click on this plus button over here. We need a machine name. We're just going to name this nitrogen applicator. The width is in feet, and this only has one section, so it can't do multiple sections at a time. And the machinery type, you can do applicator or harvester. This is an applicator, so anything that's not a combine of some sort, it's going to be an applicator. So then we're going to click save. Oh, sorry, we didn't put the width. Sorry, the width of this machine we're going to use is 40 feet. So now that we've added the machine, we don't have to add it again for this farm and field. We just need to go here and click on the N applicator, then it'll bring in these other inputs, so we now know the width. We only have one input section, so it's the same rate across the whole applicator. So now we have our trial information, headland distance, sideland distance. This is the design area. We can do a checkerboard or we can do a strip plot. Checkerboard is what we're gonna do on this specific one. So now we're gonna go to the input plot width, and this is gonna vary depending on all your machinery widths, which we'd have to just go over in conversation about your own equipment. But here, our input plot width is going to be 40 feet based on the width of the applicator. A number of rates we want to look at are 7. So our normal input range, this is kind of our standard practice, is going to be 40 gallons per acre. We're going to have a minimum of 0 gallons per acre, and we have a max of 60. So that's the rate. So it's going to choose 7 rates between 0 and 60, with one of them being 40. So then we're just going to tell it which AB line to use, and we're going to say the corn AB one that we already input, and then we're going to click done. So here it takes us back to the trials page where we've input our AB line, our trial configuration, and now it has those inputs. So we can see here, this is our corn NAB line, our checkerboard, UAN 28, and applicator 40-foot width. One section, plot width is 40. Gallons per acre, 40 is the typical rate, but we want to test rates between 0 and 60 with 7 levels. If we want to change that, we can edit that right here. If we want to look at adding seeding rates or any other inputs with phosphorus, potassium, we can add those there and kind of combine the trials. But once we're happy with this is what we're going to look at, we're going to click right there and we're going to say create trial. So then it's going to process. May take a few minutes, but it's usually pretty quick. So now after it's done with that, we're going to scroll down here, and here we're going to have some options. We go ahead and click open, and this will open a new window, and we can see a map. We can download it. This is that trial area. We can see the treatments going from 0 to 60, and we can see kind of the checkerboard design here. The light gray areas are those areas that are kind of the buffer areas that are not part of the trial, but it'll still do the default rate of the farmer's rate. It looks at about 40 gallons per acre. So we can download that map to show as well. We can go ahead and go back a screen, scroll back down. This next thing we can click on, we can click download. And what that will do is it'll bring downloads into your, it'll download some files, so we can look at those right here. So those files that it downloads, if we unzip them, and looking there, we can see these are the trials. This is all the information that you'd need for the next step of implementing it for the farmer. It has the trial design, it has the AB lines for the applicator, the AB lines for the harvester. It has the different file types you'll need to put it into SMS to make the different, to be able to put an applicator to actually apply the treatments. So that's all the files that you would need there for that. It also gives you a report. We can click on here. So this report is just some generic text, but it can go through and it will tell you how big the field is, how many plots there are, how many feet wide they are, how long they are. The rates tells you how many gallons per acre UN you'll need to do to complete the part of the field trial in this area. Then it goes down here, it'll tell you the amount of replicates for each of those rates. It's not always equal. Then we have our AB lines. These are the AB lines you'll need to apply the UAN. This is the AB line you'll need to apply for harvesting, and these might be different than the AB line that you input. So just make sure that you can use that AB line to apply the treatments exactly where you need to for the trial, as well as harvest them to get the most in the center of the trial. So it's important that we use these AB lines, not the one that was given by the farmer originally. In the next part here, we see the kind of the steps in the field trials. We scroll down, we'll see those areas in gray are those areas that will be the trial. Those areas that are red will be those border areas. The next part is kind of showing the AB lines, kind of a diagram. This is the AB line of the applicator. I'm using the AB lines described earlier, so you can see the direction of that, of the planter applicator. And then next it kind of goes into harvest. You can kind of see here the applicator will apply on a 40-foot basis, and then the harvester, to get the 40 feet, will go 20 feet this way, 20 feet back. That's why it's important to use the AB lines provided, because it helps keep these things together so we can get the best data possible. There are caveats where maybe your harvester and your applicators don't line up, and it'll kind of account for that in the data processing part later on. That can be covered later. Then it goes into kind of uploading some different things. So next, after this, after we've done all of that, we've decided, okay, that's the trial that we want. We looked at it, we're good with it. We're going to go say, okay, this is our final version of this one that we want. It'll ask us if that's yes for sure. Then it'll click OK, then it'll go ahead and design the trial and put all the official things you need for the next step. So then we go into here, we go to trials. And this is kind of a post thing right here. We're going to find our thing right here after we've we've already applied the nitrogen, we've already harvested. Then we're going to come back and we're going to manage this trial. And here you can see, kind of gives you, you can zoom in a little bit, you can see where the trial is located, it gives you the target rates, gives you the replicates for each of them, just kind of a quick trial design. And then over here, once we get the data, we're going to go ahead and upload the raw yield file, and we're going to upload the as applied data. If we don't have the as applied data, but we're sure we applied it where it should have been, we can use this button right here that says use trial design. So first of all, we're going to upload the raw yield data. So we're going to click here and go to upload. We're going to open the core nitrogen example again, and this has in it the raw yield data as the zip file right here. So we know right here the data type is yield that we're going to want to look at. So we're going to take that zip file, we're going to put it in here. It's going to process it, and then we're going to be able to click upload. Once that's done uploading, it'll bring us back here, and then we're going to do the as applied UAN data. So we have this, we're going to upload it again. We're going to get our file that has our data, and this is our raw as applied UAN data that we're going to use. So that's going to be dragged and dropped in there. Then we're going to upload it. So the next thing, now these went from upload to click on. If you did something wrong, you can always go over here and trash can them and then re-upload something, but we should have done it right. So now we're going to look at our raw yield. And now this is where we go in and define features. And this is basically so the program can know these, because it needs to know some of these to do the calculations, but it needs to know what this is in your file. So they're not all the same. It does match some. So once in here, once your elevation data. So in this one, we can go in here and look at it and choose elevation. The unit for this one is feet. The distance is this first one. Again, the unit is feet. The volume, it did find it. It says VR yield. And then it's going to be bushels per acre. The offset we're going to leave blank. The time is time. It found it correct. Angle is heading. The mass, this is if you were doing pounds per acre instead of volume per acre. You can go in there and do that, but we're not going to worry about that right now. The width is going to be the swath width. That's right here, and it's measured as feet. And the speed is going to be vehicle S. Right here, and that's in miles per hour. And then we're going to go here and we're going to click submit. Okay, so that one says it's ready right here. So now we're going to go to define features for the as applied data. In here we need our section ID, so that's going to be section. Our distance is this one right here, distance C. That's in feet. Offset we're not going to worry about. Time is time. Angle is heading. It found that correctly. Width is going to be the swath, WI. That's in feet. The speed, again, is vehicle S. Miles per hour. And this is the input rate, so it found it at APPL DRT. And this is in gallons per acre. And then we're going to click submit. And it's going to rename the columns, make sure they're appropriate. So now we've defined the features and they're ready to go. Next thing we're going to do is click on process. Our next thing we need to do is the price. Just going to use a default raw yield price of $4 a bushel, and then UAN price, we're going to say $2.50 per gallon. And then we're going to go ahead and process the data. It's going to ask you if you're sure you want to do this because it may take a minute, but it's going to go through that. It's going to start working on processing the data. We're going to skip the wait period here, and we're going to just click on, I already have a file opened. This is our core and end test. And once it's done, it's going to have this options down here. So we're going to go ahead and click view reports. And there are lots of different ones. There's the trial design, the analysis, final processing, data processing, grower, and then data processing non-experiment. So we're going to, first of all, we're just going to really focus on the grower report. These other ones are more academic in nature. Just want to look at that grower report and see what we learn. So here it's just going to be a trial summary. This is just some default information of the size, plot width, plot length, the targeted rates, producer status quo is 40 gallons per acre, $4 corn, $2.50 per gallon UAN. This goes through and kind of does a summary of the test, tells you applying the different rates and how it would do. We have our targeted rates we targeted here versus our as applied rates, and then our mean yield in each of those treatment areas, and then the profit for each one of those. This is just talking at our optimal uniform rate. If we look at all these rates, the rate that was best, that was the as applied rate, our 40 gallon was actually a 48. And that 48 optimal uniform rate across the whole field, if we were to use one, would have been 48. So if we were to switch from that 40 gallons to the 48 gallons new uniform rate, we'd gain $32 profit from switching from the status quo strategy to the optimal site specific, so that's using variable rate throughout the field in different areas. It wouldn't gain you any more money. So saying the 48 gallons per acre was across the whole field was the best there. So this is just the trial design and implementation. You can kind of see maps of what the targeted rate was versus what we applied it. So the targeted rates were the as applied were a little higher than the targeted rates here. I'm not going to go through this in lots of detail, just kind of show you some information that's here. And if you'd like more information, we could definitely meet with someone to talk more about these things. This is just looking at misalignment of where maybe the planter or the applicator was in different spots than the as-applied data. So you might have harvested an area that wasn't a treatment or a mix. So it gives you some of that there. We're not going to go in a lot of detail there. This is just kind of a yield response, a big broader picture. So this is just the average as applied UAN, the kind of categories here. You can kind of see the different targeted rates here versus what our yields were, our profit was, and this is our yields in this one right here. So you see as we increased in rate, until we kind of leveled off around in here. You can see our profit went up as we went from 18 to 26 to 31 to 40, and then that 48 rate, we had the highest bushels and the best profit. We went up to that 59, it went down. For our profit there, field characteristics, so we input some of that data. We're able to do some elevation by default, but we can also input other maybe soil test information or zone sampling and things like that as well. So you can see kind of on the low elevation what the mean yields were and the profit, on the medium elevation and on the high elevation. And this is kind of a map of your field of where those areas were. And this is just a profit level by that. You can see how it goes up until it maximizes about that 48. Kind of the same on both the low slope, medium slope, and high slope areas. And this is from data that is pulling from online resources for slope and things like that. And this is a summary of economic results, their implications, kind of going through there of how it would be changing from your current rate of 40 to 48. You get an average increase of $32 per acre. This is your optimal UAN rate. It's kind of the same across the field. Kind of again a change in management strategy, estimated gain from doing an optimal uniform rate, no additional gain, so $32 from doing the optimal uniform rate, no additional gain from doing a site-specific rate, so varying. Then next is just an overview of the data processing. Tells you the rates and the yields, kind of a yield map for each of the different rates. And here, this is a compensation calculation. So what this program tries to do is if you lost money from your status quo by doing the trial, that we can then reimburse you for that. So that kind of goes through and it analyzes your status quo data, which is in the blue, versus your trial data, to see kind of if you lost money, if you gained money based on that. And this is just another figure showing the trial data, the status quo data. And then if we kind of summarize all that, we can see here for this certain one, there are 65 observations. The profit difference was about 0. So area in the trial rate for 9 total compensation. So this farmer didn't lose money by doing the trial, so we didn't compensate him for that. But they still get the $1,000 for being part of the program. So that's kind of an overview of a nitrogen test. And we'll also do some more examples of some seeding rates and some with and without, like a product. So like pivot bio, with pivot bio and without. You can see some other videos on that.